In the deepest, coldest quiet of the cosmos, a billion miles from the sunlit world that conceived it, a new eye has opened. It is an instrument of impossible precision, a honeycomb of gold and beryllium, shielded from the warmth of its own star by a silver kite the size of a stadium. This sentinel, the James Webb Space Telescope, was not built to look at the familiar celestial neighbourhood. Its gaze is fixed on a destination far more profound. It is a time machine, designed to peer back through the eons, past the age of spiralling galaxies, beyond the genesis of stars, to the very edge of the cosmic dawn. Its mission was to affirm our story of creation, to provide the final definitive evidence for a narrative we have carefully constructed over a century of painstaking observation and brilliant deduction. We believed we knew the plot, a singular explosive beginning, a long silent darkness. Then a slow, tentative emergence of light, as the first tiny sparks of structure began to coalesce from the primordial hydrogen fog. A universe building itself piece by piece over billions of years, a majestic, orderly and comprehensible timeline. But out there, in the direction of the Sculptor constellation, Webb's unblinking eye focused on a patch of sky that appears utterly vacant to any other instrument. It gathered photons that have been travelling for more than 13 billion years, light that is older than our Sun, older than our Earth, light that began its journey when the universe itself was a mere infant. And on a screen in a quiet control room, an image began to form. There was a faint smudge of infrared, a ghostly red fingerprint on the blackness. A designation was assigned, a T25P52. And with that faint smudge, our entire story of the cosmos began to unravel. What Webb revealed in that image, and in dozens of others like it, was not the nascent, chaotic proto-galaxy our models predicted. It was something else. Something that, according to everything we thought we knew, should not exist. It was an impossibility staring back at us from the dawn of time. A discovery so profound, so paradigm-shattering, that the feeling rippling through the astronomical community is not just excitement. It is a deep, intellectual dread. A terror born from the realization that the timeline of the universe has been broken, and we may have to start our cosmic story all over again. To comprehend the magnitude of this cosmic disruption, we must first journey back to the story we thought was true. Our grand narrative of the universe, known as the Lambda cold dark matter model, is one of the most successful scientific theories ever conceived. It begins 13.8 billion years ago, not with an explosion in space, but as an explosion of space. An infinitely dense, superlatively hot point containing all matter and energy, which suddenly began to expand, carrying the very fabric of reality along with it. This was the Big Bang. In the first fractions of a second, the universe was a maelstrom of fundamental particles and unimaginable energies. As it expanded, it cooled. Within a few minutes, the first atomic nuclei, primarily hydrogen and helium, had formed. For the next 380,000 years, this primordial soup of charged particles and radiation was a blazing, opaque fog. Light could not travel freely. Photons were trapped in an endless game of pinball, scattering off free electrons. The cosmos was a featureless, incandescent plasma. Then, a crucial transition occurred. The universe cooled enough for electrons to be captured by nuclei, forming the first stable neutral atoms. This event, known as recombination, suddenly made the universe transparent. The trapped light was released in a brilliant flash that filled all of space. Today, that ancient light, stretched by the expansion of the universe into the microwave spectrum, is still visible to us as the cosmic microwave background radiation. It is the faint afterglow of creation, the oldest photograph we possess, showing a universe of almost perfect uniformity. Almost perfect. In this baby picture of the cosmos, there were infinitesimally small variations in temperature and density. These tiny fluctuations, mere ripples in the primordial sea, were the seeds of everything to come. They were the gravitational keystones upon which all future structure would be built. Following this release of light, the universe entered a period known as the Cosmic Dark Ages, For hundreds of millions of years there were no stars, no galaxies, no light. The cosmos was a vast, silent and expanding expanse of neutral hydrogen and helium gas, pervaded by the invisible scaffolding of dark matter. Imagine an endless, pitch-black ocean utterly still. In this ocean, there are invisible currents, unseen eddies and flows. This was the dark matter, a mysterious substance that does not interact with light, but whose gravity shapes the destiny of the cosmos. The tiny density ripples from the early universe meant some regions of this invisible ocean were slightly denser than others. Over immense timescales, gravity, relentless and patient, began its work. These denser regions of dark matter started to pull in the surrounding hydrogen and helium gas, like cosmic whirlpools slowly drawing in the surrounding water. Our models predicted this was a slow, deliberate bottom-up process. The first structures to form would be small, fragile clouds of gas, which would then collapse to ignite the very first generation of stars known as Population 3 stars. These were not like our Sun. They were theoretical monsters, hundreds of times more massive, forged from pure hydrogen and helium. They would have burned with an incredible blue-white intensity, but their lives would have been fleeting, lasting only a few million years before they exploded as supernovae, seeding the cosmos with the first heavy elements, the metals that are essential for life and complex structures. From the ashes of these first stars, the first protogalaxies would have been born. Think of them not as majestic spirals, but as small, messy, chaotic swarms of stars and gas. Our timeline dictated that these infant galaxies would then spend the next billion years or more in a process of cosmic cannibalism and merging. Small protogalaxies would collide, their stars and gas mixing, their gravitational pull growing. It was a hierarchical assembly, tiny streams of matter merging into larger rivers, which in turn flowed together to form the great island universes, the mature, massive galaxies like our own Milky Way that we see in the later universe. This process was thought to require vast amounts of time. The universe needed to patiently build itself up. This was the timeline. A dark age lasting for perhaps 400 million years, followed by a slow cosmic dawn, and then a long, gradual period of construction. Our previous great observatories, like the Hubble Space Telescope, gave us glimpses into this era. They saw distant, small, bluish galaxies that seemed to fit the narrative perfectly. They were the cosmic toddlers we expected to find. The story held together. It was elegant, supported by evidence, and it made sense, until we sent a new messenger into the void. The James Webb Space Telescope is the culmination of a dream that began before its predecessor Hubble had even left the ground. Scientists knew that to see the very first light, they needed a different kind of eye. As the universe expands, it stretches the fabric of space-time itself. Light travelling through this stretching fabric is also stretched, its wavelength shifted towards the red end of the spectrum. This is cosmological redshift. The farther away an object is, the faster it recedes from us, and the more its light is redshifted. The light from the very first stars and galaxies has been stretched so profoundly that by the time it reaches us, 13.8 billion years later, it is no longer visible light. It has been transformed into the longer wavelengths of infrared radiation. Our planet's atmosphere is opaque to most infrared light. More critically, the Earth, the Moon, and even the telescope itself glow with their own infrared heat, which would blind any sensitive detector. To see the faint infrared whispers from the cosmic dawn, a telescope had to be incredibly cold and stationed far from Earth. This was the genesis of Webb, an engineering challenge of staggering complexity. A primary mirror composed of 18 hexagonal segments of beryllium, each polished to near atomic perfection and coated in a microscopically thin layer of pure gold, chosen for its supreme reflectivity of infrared light. When unfolded in space, this mirror forms a single, light-collecting surface over 6.5 meters across, the largest ever launched into orbit. To keep it cold, unimaginably cold, at nearly 230 degrees below 0 Celsius, it required a sunshield. A 5-layered membrane of a material called capton, each layer thinner than a human hair, which would unfold in space to the size of a tennis court. This magnificent silver shield would permanently block the light and heat from the Sun, Earth and Moon, allowing the telescope to cool to its cryogenic operating temperature. It was a cosmic origami project of 1 million moving parts, all of which had to work perfectly, with no possibility of a repair mission. Its destination was a unique point in space 1 million miles from Earth, the second Lagrange point, or L2, a place where the gravitational pull of the Sun and Earth balance, allowing the telescope to remain in a stable position, its sunshield always pointing towards home. After decades of development, billions of dollars, and moments when the entire project was on the brink of cancellation, the telescope was launched on Christmas Day, 2021. For a month, the world held its breath as it performed its complex autonomous deployment sequence. It unfolded its solar panels, its antennas, its sunshield, its mirrors. Each step was a potential point of catastrophic failure. Each step succeeded flawlessly. The Golden Eye had arrived at its post, cooled down and open for business. It was ready to look back into the abyss and confirm our elegant story. The first deep field images were a watershed moment. Where Hubble had seen a handful of faint smudges in the distant universe, Webb revealed a tapestry of thousands upon thousands of galaxies, scattered like jewels on black velvet, reaching back to an epoch we had never seen with such clarity. And that is when the unease began. The initial surprise was just how many galaxies there were. The early universe was far more crowded, far more luminous than we had anticipated. But the true shock came when scientists began to analyze the properties of these newfound ancient objects. This brings us back to that single, unassuming smudge of light, a T25P52, and its many brethren discovered in Webb's initial surveys. When astronomers measured its redshift, they found it was astonishingly high. The light from this object had been travelling for over 13.4 billion years. We were seeing it as it was when the universe was less than 400 million years old. According to our timeline, this was the moment of cosmic dawn. At this stage, we expected to find, at best, a small chaotic cluster of population 3 stars, a mere protogalaxy still in the process of being born. Instead, what Webb saw was a galaxy. A fully fledged, well-behaved galaxy. When they measured its light, they found it was not only surprisingly bright, but surprisingly massive. Its stellar mass was estimated to be in the billions of solar masses, perhaps tens of billions. This was not a small stream. This was already a river. To accumulate that much mass, that many stars in such a short amount of time after the Big Bang, is a profound mystery. It's like arriving at a construction site a few minutes after the groundbreaking ceremony and finding a completed 40-story skyscraper already standing, with the lights on and tenants inside. The timeline simply does not add up. There does not seem to have been enough time for gravity to do its slow, patient work of gathering all that material together. The second shock was the galaxy's colour. In astronomical terms, a galaxy's colour tells a story about its stellar population. Young, hot, massive stars burn with a brilliant blue light. Older, cooler, more evolved stars shine with a redder hue. The galaxies of the early universe were expected to be overwhelmingly blue, dominated by the first generations of furious young stars. A T25P52, however, was disturbingly red. This indicated the presence of an older, more mature stellar population. It implied that this galaxy wasn't just being born, it had been forming stars for a significant period before the moment we were observing it. It was a cosmic fossil found in the universe's nursery. It suggested that the clock of star formation started ticking much, much earlier than we ever imagined. Perhaps the most damning piece of evidence came from the spectroscopy. By splitting the galaxy's faint light into its constituent colours, astronomers can look for the chemical fingerprints of different elements. As predicted, they found hydrogen and helium, but they also found signatures of heavier elements: carbon, oxygen, neon. These elements are not created in the Big Bang. They are forged exclusively in the nuclear furnaces of stars and scattered through space when those stars die. To have a significant abundance of these metals in a galaxy at 400 million years post-Big Bang means that at least one entire generation of massive stars had already been born, lived out its full life cycle, and exploded. enriching the surrounding gas from which a second generation of stars, the one we're observing, then formed. The established timeline is shattered by this observation. It demands an impossibly compressed sequence of events. The universe had to cool down, form neutral atoms, allow gravity to gather gas into the first dark matter halos, ignite the first population 3 stars, have those stars live and die, and then reaccumulate the enriched gas to form a second massive generation of stars in a well-ordered galaxy, all within a cosmic blink of an eye. The model simply cannot account for this speed. It is a cosmological paradox, and this is the source of the terror rippling through the scientific community. It's not the fear of a monster lurking in the dark. It is the exhilarating, gut-wrenching anxiety of a cartographer who, having spent a lifetime mapping a continent, is suddenly presented with incontrovertible proof that the continent is shaped completely differently, or perhaps is not even where they thought it was. Every chart is wrong. Every assumption is questioned. The foundations of their understanding have crumbled. The initial reaction was one of disbelief and caution. Could the instrument be wrong? Perhaps the calibration of Webb's detectors was slightly off, but the results were confirmed again and again across different instruments on the telescope and in different patches of the sky. The impossible galaxies were real. The data was robust. Could the analysis be flawed? Perhaps these objects are not what they seem. One early hypothesis was that they weren't galaxies at all, but rather supermassive black holes in their early quasar phase, accreting matter and glowing with ferocious intensity. This could make them appear brighter and more massive than they truly are. While some of these objects may indeed be quasars, this explanation cannot account for the sheer number and diversity of the anomalous galaxies being discovered. Many of them show the clear, distributed light of stars, not the point-like glare of a single quasar. Another possibility is that we are fundamentally misunderstanding the nature of the first stars. Our models of the population 3 stars as individual isolated behemoths might be too simplistic. What if they formed in extraordinarily dense, massive star clusters, triggering a chain reaction of starbirth that was far more efficient and explosive than we ever imagined? Perhaps the process of star formation in the pristine, metal-poor environment of the early universe is governed by a different set of physical rules. This would require a major revision of our theories of stellar evolution, but it would at least keep the larger Big Bang framework intact. A more radical line of inquiry points to the invisible engine of the cosmos, dark matter. The Standard Model is called Lambda cold dark matter because it assumes the dark matter particles are cold, meaning they move slowly. This allows them to clump together easily into the small halos needed for the bottom-up, hierarchical model of galaxy formation. But what if dark matter is warm, or has other properties we haven't considered? A different kind of dark matter might form larger halos much more quickly, providing the massive gravitational cradles needed to build huge galaxies in a cosmic hurry. This would mean overturning decades of cosmological theory, forcing us to rethink the very nature of 85% of the matter in our universe. And then there is the most terrifying possibility of all, the one that few dare to speak of too loudly, but that lingers in the back of every cosmologist's mind. What if the problem is not with our understanding of stars or dark matter, but with our understanding of the very beginning? What if the timeline itself is wrong? The age of these galaxies is determined by their redshift, and our calculation of that redshift's meaning is directly tied to the expansion rate and age of the universe as dictated by the Big Bang model. If these galaxies are as mature as they appear, perhaps they simply had more time to develop. Could the universe be older than 13.8 billion years? This would contradict a wealth of other evidence, from the cosmic microwave background to the observed abundances of light elements. But alternative cosmological models exist. Some propose a big bounce, a cyclical universe where our Big Bang was not a beginning, but merely a transition from a previous contracting cosmic phase. In such a scenario, structure could have survived the bounce, providing a head start for galaxy formation in our current epoch. These ideas have long been on the fringes of cosmology, but discoveries like AT25P52 are forcing scientists to give them a second, more serious look. The implications are profound. Our entire cosmic origin story is predicated on the idea of a beginning, a day zero from which everything else unfolds in a predictable, law-abiding sequence. Webb's impossible galaxies challenge this linearity. They are like finding a modern human skeleton in a layer of Cambrian rock. The existence of the fossil doesn't just disrupt the timeline, it forces a complete re-evaluation of the entire process of evolution. We're in a similar moment. This is a crisis for cosmology, but it is also its greatest opportunity. Science does not progress by confirming what it already knows. It leaps forward when it is confronted with an anomaly, a mystery that cannot be explained by the current paradigm. The terror that scientists feel is the thrill of standing on the precipice of a new understanding. It is the awe of realizing the universe is not only stranger than we imagine, but stranger than we can imagine. The rulebook is being thrown out, and a new one must be written. The next few years will be a period of frantic activity and brilliant innovation. Webb will move from discovery to diagnostics. Its powerful spectrographs will be trained on these cosmic paradoxes for hundreds of hours, painstakingly dissecting their light to get a definitive census of their chemical composition, their stellar ages, and the motions of their gas. We will determine if they are truly as massive and mature as they seem. New theoretical models will be built, old ones will be discarded. The supercomputers of the world will run simulations of early universe physics with new inputs, trying to find a sequence of events, any sequence, that can build these cosmic behemoths in the time allotted. We built the James Webb Space Telescope as the final chapter in our book of the cosmos, believing it would write the concluding sentences and confirm the triumphant plot. Instead, it has torn the book apart. It has shown us that the first pages are far more complex and dramatic than we ever conceived. It has given us a glimpse of a cosmic genesis that was not slow and steady, but perhaps violent, rapid, and driven by physical processes we do not yet comprehend. Out in the cold darkness, the golden eye continues its silent vigil, gathering the ancient light. Each photon it collects is a clue in the greatest detective story of all. A story whose beginning we thought we knew, but now find is shrouded in a new and deeper mystery. The timeline is not so much broken, as it is revealed to be a far richer, more intricate and more surprising tapestry than we ever dared to hope. The terror gives way to wonder. We are not lost. We are simply at the beginning of a much grander journey. The universe has thrown down a challenge, and the adventure of answering it has just begun. The Pacific Ocean lies beneath a shroud of deep indigo, its surface reflecting a sky that has remained unchanged in its essential character for millions of years. Atop the volcanic peak of Haleakala, the air is thin and cold, a crystalline medium through which the light of distant suns passes with minimal interference. Here, the machines of the Asteroid Terrestrial Impact Last Alert System maintain a tireless vigil. They do not sleep, nor do they blink. Their silicon eyes are tuned to the subtlest shifts in the darkness, searching for the movement of stones that might threaten the world below. In the closing months of 2023, one such sensor recorded a sequence of photons that would shatter the quiet assumptions of local celestial mechanics. It appeared first as a mere flicker, a microscopic deviation in the expected pattern of the stars. In the language of the cosmos, movement is the primary indicator of identity. Most objects within the local neighbourhood follow the predictable circular paths dictated by the sun's immense gravity. They are the permanent residents of this solar system, bound by the invisible tethers of an elliptical dance that has continued since the planets first congealed from a disk of dust and gas. But this new arrival, designated 3I Atlas, possessed a signature that was alien to the local order. It did not curve toward the sun with the sluggish submission of a common asteroid. Instead, it cut through the plane of the ecliptic with a velocity that defied the sun's ability to capture it. The trajectory was hyperbolic, a geometry that speaks of a beginning in the deep void and an ending in the same. It was a line drawn across the heavens that would never close into a loop. This was not a rock that had spent the last 4 billion years orbiting within the Kuiper belt or the Oort cloud. It was a traveller. The mathematics of its flight revealed a hyperbolic excess velocity so high that it could only have originated from the interstellar medium, the vast empty reaches that separate the stars. It moved with a momentum gathered from a distant unknown source, flung into the dark like a stone skipped across the surface of a still pond. This object is a letter, though it bears no ink and is written upon no parchment. Its script is composed of trajectory and velocity, its grammar defined by the laws of motion. It is a correspondence tossed into a celestial tide by a hand that may have long ago crumbled into dust. For eons this message drifted through the vacuum, a bottle thrown into a sea of stars where the concept of distance loses all human meaning. It carried within its cold, metallic heart the story of a home system that may no longer exist, a place where the light of a different sun once warmed the surfaces of different worlds. Before the first ancestors of humanity learned to gaze into the flicker of a fire, this object was already in motion. It has crossed the silent gulfs where the light of the Milky Way is the only companion. It has weathered the bombardment of cosmic rays and the erosive touch of the interstellar wind. It arrived in our neighbourhood not as a conqueror, but as a silent witness to its own survival. The sensors in Hawaii were merely the accidental recipients of a postmark that has been in transit for hundreds of thousands of years. We are the unintended audience of a performance that began in the deep past and will continue long after our own sun has begun its slow expansion into a red giant. As the data streamed into the computers of the astronomers, the realization dawned that the silence of the cosmos is not an absence of information, but a backlog of unread mail. We have spent centuries looking for signals in the radio spectrum, listening for the hum of artificial transmissions, yet we failed to consider that the message might arrive as a physical artifact. 3i Atlas is a physical manifestation of an elsewhere and an elsewhen. It is a tangible link to a reality that exists far beyond the reach of our current probes. It does not speak in radio waves, it speaks in the language of mass and speed. The object does not arrive in an envelope, but as a silent streak of light across the sensors of a lonely telescope. It has drifted through the vacuum, a piece of cosmic debris that carries the chemical signature of a birthplace we cannot see. Its path tells a story of a system long since vanished or a purpose we are only now beginning to decipher. The vacuum of space is often described as empty, yet it is a repository for the remnants of everything that ever was. Every star that dies, every planet that is torn asunder, and every civilization that reaches for the stars leaves a mark upon the void. 3i Atlas is one such mark. Its arrival marks the third time in human history that we've identified a visitor from beyond the sun's reach, yet its characteristics are far more provocative than those of the objects that came before it. As it accelerated past our sun with a precision that defies simple chemistry, the scientific community was forced to confront a haunting possibility. Is this a random stone, or is it a greeting? We are the accidental recipients of a correspondence that has been travelling since before our species had a name for the stars. Today, the letter has finally been opened. The data is cold and the numbers do not care for our emotional response to the vastness of the universe. Yet there is an inherent drama in the way this object moved through our local space. It did not merely pass by, it announced its presence through the sheer defiance of its orbital mechanics. It challenged our understanding of what an interstellar object should be. It moved with a grace that suggested something other than the chaotic tumbling of a natural rock. In the quiet of the Hawaiian night, the sensors captured the first syllables of a story that spans the galaxy, a narrative of survival and travel that transcends the brief flicker of human civilization. We are now the observers of a journey that began in the heart of a distant star system, and by watching it, we become part of its history. To understand the gravity of this moment, one must look back to the first time the veil was pierced and the silent isolation of our solar system was interrupted. The arrival of 3i Atlas is not an isolated event, but the third chapter in a trilogy of cosmic intrusions that have fundamentally altered our perspective on the interstellar medium. Before this latest messenger, there were others, each serving as a precursor that prepared the scientific mind for the extraordinary. In October of 2017, the Pan-STARRS 1 telescope on the island of Maui captured a faint point of light moving with a velocity that defied the Sun's gravitational grip. This was One-Eye Oumuamua, a name derived from the Hawaiian word for a scout or messenger, sent from the distant past to reach out to us. It was a sliver of matter, estimated to be 10 times longer than it was wide, a geometry unseen among the hundreds of thousands of asteroids and comets documented by human science. As it rounded the Sun, it did not merely follow the path dictated by mass and distance. It exhibited a subtle but distinct non-gravitational acceleration. In the natural world, such a push usually results from the sublimation of ice, where heating causes gas to erupt from the surface like a thruster, yet Oumuamua remained clean. No veil of gas, no shroud of dust, and no streaming tail followed in its wake. It was a silent, dark splinter, tumbling through the void with a reddish hue that suggested eons of exposure to cosmic radiation. It left as quickly as it arrived, leaving behind a wake of controversy and the first serious whispers that we might be looking at something artificial, a piece of derelict technology rather than a random stone. The narrative shifted toward the familiar 2 years later, in August of 2019. Gennady Borisov, an amateur astronomer using a telescope he had fashioned with his own hands, spotted a second intruder. This object, designated 2I Borisov, was the antithesis of the first. It was a classic comet, a dirty snowball of ice and rock that announced its presence with a glowing shroud of vapour and a long streaming tail of dust. As it approached the Sun, it behaved exactly as a comet should, outgassing its volatile components into the vacuum. Spectroscopic analysis revealed the presence of cyanogen and carbon monoxide, the very same chemicals that constitute the icy bodies of our own Oort cloud. Borisov was a nomad that looked like a native, a reassuring proof that the fundamental chemistry of planetary formation elsewhere in the galaxy often mirrors our own. It was a sign that the universe followed a recognizable blueprint, and for a moment, the mystery of Oumuamua seemed like a singular anomaly. But 3I Atlas, detected in the waning months of 2023 by the Asteroid Terrestrial Impact Last Alert system, shattered that burgeoning sense of familiarity and returned the scientific community to a state of profound uncertainty. It did not possess the icy volatility of Borisov, nor did it share the mere structural oddity of Oumuamua. It was something else entirely, a candidate that pushed the boundaries of natural explanation into the realm of the synthetic. While Oumuamua had been a mystery, 3I Atlas was a provocation. The contrast between these three visitors is stark. Borisov was a messenger of the known, a bridge between our chemistry and the chemistry of a distant star. Oumuamua was a messenger of the strange, a physical shape that challenged our models of how rocks are formed and how they move. 3I Atlas, however, is a messenger of the impossible. Its velocity was not merely high, it was extreme, suggesting a birth in a high-energy environment far more violent than the quiet outskirts of a typical star system. Where Borisov was dark as soot, reflecting only a tiny fraction of the light that hit it, 3I Atlas gleamed with a brilliance that seemed to defy the wear and tear of interstellar travel. This third visitor does not tumble with the chaotic, uneven rhythm of a broken rock. Its interaction with solar radiation is far more pronounced than any natural object of its size should allow, behaving as if it were constructed specifically to catch the light. It represents a leap in complexity and strangeness. If Borisov was a natural stone and Oumuamua was a curious shard, 3I Atlas is a polished mirror, reflecting back at us the limitations of our own understanding. It stands apart from its predecessors, not just in its speed, but in its very essence. It is the most artificial candidate yet encountered, a structure that appears to have been designed rather than grown, or at the very least, a natural phenomenon so rare that it occupies a category of one. As it cut through the plane of our planets, 3I Atlas did not just pass by. It demanded a re-evaluation of everything we thought we knew about the contents of the interstellar void. We are no longer looking at a universe filled only with the debris of dead stars and the frozen remnants of planetary births. We are looking at a space that contains objects of high energy and high reflectivity, objects that move with a precision that suggests a history far more complex than a simple gravitational kick. The lineage of visitors has led us to this point, from the familiar comet to the strange splinter, and finally to this gleaming enigma that now races away from us, leaving a trail of data that points toward an origin we can barely conceive. The defining characteristic of 3I Atlas is its sheer, unrelenting momentum. In the cold bookkeeping of orbital mechanics, the most vital metric is hyperbolic excess velocity, the speed an object retains after it has climbed out of the gravitational well of its home star and ventured into the true void. For this visitor, that value is measured at 62 kilometers per second. To the human mind, accustomed to the slow crawl of terrestrial travel, such a number is difficult to grasp. It is a speed that would cross the entire diameter of the Earth in less than 4 minutes. Within the local context of our solar system, where objects typically drift at much more modest paces relative to the Sun, this velocity is a profound anomaly. Consider the comparison to its predecessors. 1I. Oumuamua entered our neighbourhood at a relatively sedate 26 kilometers per second. While that speed was sufficient to prove its interstellar origin, it fell within the expected range for objects ejected from nearby star systems through standard gravitational interactions. 62 kilometers per second, however, places 3I Atlas in a different category of kinetic energy. It is moving more than twice as fast as the first messenger, a disparity that demands an explanation beyond the ordinary. The Sun, for all its immense mass, is unable to do more than slightly deflect the path of such a high-speed traveller. It is as if a freight train were being nudged by a summer breeze. The trajectory remains largely unbowed, cutting through the solar system with the indifference of a bullet. The physics of this speed suggest a violent and energetic birth. For a natural object to achieve such a velocity, it must have been subjected to a gravitational kick of immense proportions. One possibility lies in the dense, chaotic heart of the galaxy. In the galactic core, where stars are packed together like grains of sand and a supermassive black hole exerts its titanic influence, the gravitational environment is a churning cauldron of energy. A three-body interaction, where a star, a planet, or a large rock passes too close to a binary star system or a black hole, can result in one of the participants being flung outward at extreme speeds. This is the celestial slingshot, a process that robs one object of its orbital energy to grant another an express ticket to the intergalactic dark. If 3I Atlas is a product of this process, it is a refugee from the most crowded and volatile regions of the Milky Way, a fragment of a world that was literally torn from its home and cast into exile. Yet, the 62 kilometers per second threshold also invites a more provocative interpretation. Natural slingshots are chaotic and rare, often resulting in the destruction of the object being ejected. To maintain such a high velocity while remaining intact suggests a level of structural integrity that is uncommon for loose piles of rubble or fragile icy comets. If the object is not a victim of a galactic accident, it might be the product of a deliberate propulsion system. In the realm of theoretical physics, an interstellar probe designed to bridge the gaps between stars in a human-centric time frame would need to achieve velocities exactly like this. By utilizing a light sail or a high-efficiency engine, a civilization could impart a specific high-energy kick to a craft, ensuring it reaches its destination before the eons have eroded its purpose. This speed also dictates the timeline of its journey. At 62 kilometers per second, 3I Atlas could cross the distance between the Sun and the nearest star, Proxima Centauri, in approximately 20,000 years. While this is still a vast duration by the standards of human history, it is a mere heartbeat in cosmic time. It suggests that this object is not a billion-year-old relic of the galaxy's infancy, but perhaps a more recent arrival on the galactic stage. It is a fresh message, still carrying the heat of its origin, whether the origin was the scream of a black hole's gravity or the silent push of an alien laser. The energy required to accelerate a mass of this size to such a velocity is staggering. It speaks of a source that operates on a scale far beyond our current technological capabilities. Whether it is the raw power of the galactic centre or the sophisticated engineering of a distant intelligence, the result is the same, an object that refuses to be bound by the local laws of the Sun's kingdom. It is a kinetic intruder, a testament to the fact that the universe is not a static collection of orbiting bodies, but a dynamic and often violent arena where matter is constantly being accelerated to the limits of what physics allows. As we track its departure, we're not just watching a rock fade into the dark, we are witnessing the dissipation of a massive amount of energy, a lingering echo of a monumental event that occurred somewhere deep in the star-drenched distance. The significance of 62 kilometers per second cannot be overstated. It is the signature of an outsider that has travelled far and fast, a number that separates the local debris from the true wanderers of the void. It tells us that 3i Atlas did not come from a neighbour, but from a place of high energy and ancient power. It is a reminder that our solar system is a quiet backwater, occasionally visited by emissaries from the high-velocity currents of the wider galaxy. Each kilometre per second above the norm is a word in a sentence we are still trying to translate, a clue to the nature of the forces that shaped this object and sent it on its lonely, high-speed vigil through the stars. By the time the summer of 2024 arrived, the scientific community had established a rigorous baseline for the object's trajectory. In the clockwork universe of Isaac Newton, an object in motion remains in motion, unless acted upon by an external force, and for a body travelling through the solar system, that force is almost exclusively the gravity of the Sun and the planets. Astronomers used these centuries-old equations to plot the future position of 3i Atlas with a precision that should have been absolute. Yet, as the data from June of that year began to accumulate, a hairline fracture appeared in the mathematical model. The object was not where it was supposed to be. It was drifting, pushing ahead of its predicted coordinates by a small but undeniable margin. This phenomenon, known as non-gravitational acceleration, is the hallmark of a body that possesses its own internal or external source of thrust. In the vast majority of cases, this is the result of a comet approaching the Sun and beginning to thaw. As the solar heat penetrates the icy crust of a comet, pockets of frozen gas are vaporized, erupting from the surface in violent jets. This outgassing acts like a natural rocket engine, providing a gentle but persistent nudge that alters the object's path. However, when the most powerful telescopes on Earth and in orbit were turned toward 3i Atlas to find the source of this extra speed, they found nothing but an obstinate ringing silence. There was no coma, the glowing shroud of gas that typically surrounds a melting comet. There was no tail, the long streaming banner of dust and ions that should have stretched for millions of kilometers behind a body undergoing such an acceleration. Even the most sensitive infrared instruments, capable of detecting the faint heat signature of a single molecule of evaporating water, reported a vacuum that was perfectly clear. The space around 3i Atlas remained as empty as the void itself. This absence of outgassing eliminated the possibility of traditional chemical propulsion or natural volatile activity. The object was accelerating, but it was doing so without the visible expenditure of mass. This realization transformed the object from a mere curiosity into a haunting enigma. It began to be described in the halls of research institutions as a ghost ship, a vessel that moved through the solar system while refusing to follow the simple laws of falling bodies. In the history of astronomy, the motion of celestial objects has always been a passive affair. They are the captives of gravity, falling forever toward the largest mass in their vicinity. But 3i Atlas seemed to be exercising a form of agency. It was as if the vacuum itself were providing a subtle lift, allowing the object to glide across the gravitational currents rather than merely being swept away by them. The precision of the deviation was particularly unsettling. The acceleration was smooth and continuous, lacking the erratic pulses that characterize the uneven venting of a natural comet. It suggested a force that was being applied evenly across the entire structure. This was the behavior of a craft, not a crumbling pile of cosmic rubble. the data whispered of a rebellion against the dictates of the sun. While every other asteroid and planet in the system obeyed the invisible tethers of the solar mass, 3i Atlas was pulling away, asserting a different set of physics. The implications of this drift were profound. If the object was not being pushed by escaping gas, then the force must be coming from the light of the sun itself. This pointed toward a physical structure that was incredibly thin and light, something with a surface area so vast compared to its total mass that the mere pressure of photons, the particles of light, could act as a propellant. Such a structure does not occur in nature. In the natural world, rocks are dense and compact. They do not possess the gossamer thinness required to be moved by the gentle breath of starlight. The ghost ship was revealing its true nature through its refusal to be a heavy, passive stone. This non-gravitational push turned the object into a mirror of our own technological aspirations. For decades, human engineers have theorized about the light sail as a means of interstellar travel, a way to move between the stars without the need for heavy fuel. To see this theory manifested in an object of unknown origin was to stand in the presence of a finished masterpiece, while we were still sketching the first outlines. 3i Atlas was not just a visitor. It was a demonstration of a physics we had only dreamt of mastering. It sailed through the neighbourhood of Earth like a phantom clipper, its invisible sails filled by the radiance of our sun, moving with a purpose that remained frustratingly out of reach. As the month of June 2024 drew to a close, the scientific consensus began to shift. The stone model was dying, replaced by the reality of a structure that interacted with light in a way that was fundamentally different from anything we had ever seen. The ghost ship continued its outward journey, gaining speed with every passing day, a silent metallic sliver that had turned the sun's own energy into a means of escape. It left behind a trail of unanswered questions, a mechanical ghost haunting the suburbs of our solar system, proving that even in a universe governed by the cold laws of gravity, there is still room for the impossible to take flight. The mechanism behind this defiance of gravity lies in the very nature of light itself. The sun acts as a gargantuan engine of electromagnetic radiation, flooding the vacuum with an endless torrent of photons. These massless particles are the messengers of the electromagnetic force, and while they lack the weight of matter, they possess a fundamental property known as momentum. As these particles traverse the void at the ultimate speed limit of the universe, they carry with them a minute quantity of kinetic potential. When a photon strikes a surface, it does not simply vanish. It transfers its momentum to the object it hits. This phenomenon, known as radiation pressure, is a constant and ubiquitous force throughout the cosmos, yet its influence is usually masked by the overwhelming dominance of gravity. For a massive, dense body like a planet or a moon, the pressure of sunlight is an utterly negligible whisper. The billions of tons of rock and iron that constitute the Earth are far too heavy to be moved by the gentle touch of starlight. However, for an object with a specific and radical architecture, the sun's light ceases to be a mere illumination and becomes a powerful, inexhaustible propellant. This is the principle of the light sail, a concept that demands a departure from the standard density of celestial bodies. To be susceptible to the push of photons, 3i Atlas must possess a surface area to mass ratio that borders on the ethereal. The physics of its observed drift dictates a structure that is incredibly vast in its reach but nearly non-existent in its weight. The object must be envisioned not as a solid block of stone, but as a shimmering metallic membrane. For the radiation pressure of the sun to achieve the acceleration recorded in the summer of 2024, 3i Atlas would need to be a sheet of material perhaps no thicker than a single human hair, yet spanning a length equivalent to hundreds of meters. In this configuration, the object becomes a cosmic kite, catching the solar wind of light. Each second, trillions upon trillions of photons collide with its surface. Individually, these impacts are weaker than the footfall of an insect, but in their staggering aggregate, they become a steady and relentless force. They act as a silent, invisible hand, pushing the object away from the sun with a persistence that gravity cannot fully counteract. The efficiency of this light-driven propulsion is further amplified by the reflectivity of the object's surface. When a surface is dark, it absorbs the photons, receiving a single measure of momentum. But when a surface is highly reflective, the physics of the interaction changes. The photon must be stopped and then reflected back in the opposite direction, a process that imparts twice the momentum to the sail. The data suggests that 3i Atlas is a near-perfect mirror, reflecting almost all of the light that strikes it. This high albedo ensures that it extracts the maximum possible energy from the solar radiation, turning the sun into a distant luminous engine that drives the object deeper into the dark. This is a form of travel that requires no combustion, no heavy fuel tanks, and no complex internal machinery. It is a passive, elegant interaction between matter and energy. The sun provides the wind, and the object provides the sail. It is a technology that leverages the fundamental constants of the universe to bridge the colossal distances between the stars. Such a structure does not occur through the random collisions of gas and dust in a collapsing nebula. Nature builds spheres and jagged shards. It does not manufacture gossamer-thin sheets of reflective alloy. The existence of the light sail effect in 3i Atlas points toward a history of deliberate construction, a design intended to harness the very light of the stars to traverse the vacuum. The object glides across the gravitational currents of the solar system, like a phantom clipper on a light-swept sea. It treats the vacuum not as a barrier, but as a medium through which it can sail indefinitely, provided there is a star nearby to fill its metallic expanse with photons. This steady, silent push has allowed it to deviate from the path of a simple falling body, granting it a degree of freedom that no asteroid can claim. It is a ghost ship that finds its strength in the ephemeral, a vessel that has turned the radiance of our own sun into the means of its departure. As it moves further away, the pressure of the light will gradually weaken, but the momentum it has gathered will remain, carrying this metallic messenger back into the interstellar night from which it emerged. The realization of this effect transforms our understanding of the object's intent, if such a word can be applied to a derelict. It was not meant to stay. It was not meant to orbit. It was designed to pass through, using the energy of each star it encounters to maintain its high-speed vigil. The light sail is the ultimate tool of the long-distance wanderer, a way to move forever without ever running out of fuel. By witnessing this effect, we are seeing the signature of a civilization that has mastered the art of the cosmic voyage, leaving behind a shimmering relic that continues to sail long after its creators have faded into the silence of the past. We are watching the physics of light manifest as the poetry of motion, a silent dance between a star and a sail that spans the breadth of the galaxy. The brilliance of 3i Atlas presents a challenge to the established order of the celestial inventory, manifesting as what astronomers call the albedo paradox. Albedo is the measure of a surface's reflectivity, a scale where 0 represents the total absorption of a void and 1 represents the perfect reflection of a mirror. Most objects in the deep reaches of space are dark, their surfaces weathered by eons of exposure to the relentless bombardment of cosmic rays and micrometeoroids. This process, known as space weathering, typically turns even the brightest minerals into a dull, charcoal-coloured husk. Yet, the spectroscopic analysis of this visitor revealed a reflectivity of 0.9. This means that 90% of the light that strikes the object is cast back into the void, a value so high it suggests a surface of nearly pristine purity. In the natural world, such high reflectivity is exceedingly rare. It is found only in the most extreme environments, such as the freshly fallen snow on a terrestrial mountain peak, or the crystalline ice shells of moons like Enceladus, where active geysers constantly coat the surface in a new layer of frozen water. For a moment, researchers considered whether 3i Atlas might be a fragment of such a world, a shard of pure ice ejected from a distant planetary system. However, the laws of thermodynamics quickly dismantled this hypothesis. As the object approached the Sun, it was subjected to temperatures that would cause any known form of ice to sublimate, turning directly from a solid into a gas. This process would have created a visible coma and a streaming tail, Yet, as previously observed, the object remained perfectly clean, its surface stable and silent even under the searing glare of the solar forge. The paradox deepens when considering the duration of its journey. An object travelling through the interstellar medium for hundreds of thousands of years should be coated in a layer of organic tholins and dust, a dark patina that would drop its albedo to a fraction of its current value. To maintain a reflectivity of 90% after crossing the light years is a feat that defies the standard models of cosmic erosion. It implies that the material of 3I Atlas is either fundamentally resistant to the degradation of space, or that it possesses a composition that is not found in the typical catalogue of planetary minerals. If it is not ice and it is not a weathered rock, then the logic of elimination points toward a synthetic origin. The spectroscopic signature of the reflected light provides the final clue. The way the object scatters the various wavelengths of the solar spectrum is consistent with the properties of metals. Specifically, the data aligns with the characteristics of a high-performance aluminum equivalent alloy. On Earth, we use such materials for their strength, their lightness, and their ability to reflect heat and radiation. In the vacuum of space, a thin sheet of such an alloy would be the ideal material for a light sail. It would provide the necessary surface area to catch the momentum of photons while remaining light enough to be propelled to extreme velocities. Moreover, a metallic surface would not sublimate like ice. It would remain structurally sound even as it absorbed the energy of a nearby star. This metallic nature turns the object into a shimmering beacon against the blackness of the ecliptic. It is a mirror world in miniature, a structure that has been polished to a degree that suggests deliberate manufacture. Nature does not produce sheets of aluminum alloy in the heart of a nebula, nor does it arrange them into geometries that reflect 90% of incident light. The albedo of 3I Atlas is a signature of intent. It is the glint of a tool, the shine of a machine that was built to endure the harsh conditions of the interstellar void without losing its luster. By reflecting the light of our sun so efficiently, the object is effectively announcing its artificiality, standing out from the dark, jagged debris of the solar system like a silver needle in a pile of coal. The implications of this metallic composition are staggering. It suggests a level of metallurgical sophistication that matches or exceeds our own. To create a material that can maintain such high reflectivity over cosmic timescales requires a mastery of material science that can withstand the abrasive touch of the interstellar wind. We are looking at a substance that was engineered to be a permanent inhabitant of the vacuum, a surface designed to interact with light as a source of power rather than merely a source of heat. The albedo paradox is not a mystery to be solved by finding a rare kind of ice. It is a revelation of a different kind of existence, a synthetic reality that has crossed the gulf between stars to remind us that the universe contains more than just the dust of dead worlds. As 3I Atlas continues its retreat into the outer solar system, its brilliance remains a haunting reminder of its origins. Even as the sun's light grows dimmer with distance, the object will continue to reflect 90% of whatever faint starlight reaches it, a shimmering ghost of a civilization that understood the value of a mirror. It is a testament to the endurance of the synthetic, a proof that while the works of nature may crumble and darken, the works of intelligence can be made to shine across the eons. We are left to wonder about the hands or the machines that polished this surface, and the purpose that required such a perfect reflection of the stars. The light reflected from the surface of 3I Atlas provides only half of the story. The other half is written in the staggering geometry of its physical form. Through the rigorous modelling conducted by the researchers of the Galileo project, a picture of the object's dimensions has emerged that defies every natural precedent. The data suggests a structure measuring approximately 100 metres in length, a scale comparable to the great cathedrals of the Old World or the massive rockets that first carried humanity into orbit. Yet this monolithic length is paired with a thickness that is almost spectral. The object is estimated to be only a few millimetres thick across its entire span. This is the geometry of a ghost, a sheet of material as wide as a city block but thinner than a pane of glass. are proportions that would be impossible for any natural process of accretion or fragmentation to produce. In the chaotic environment where planets and asteroids are born, gravity and collisions favour the compact and the spherical. Even the most elongated asteroids known to science possess a three-dimensional depth that ensures their structural integrity. A natural object with the proportions of 3I Atlas would be torn apart by the slightest tidal forces or the internal stresses of its own rotation. To maintain such a gossamer-thin profile over a length of 100 metres requires a level of structural stability that points directly to advanced engineering. It is a form designed to maximise surface area while minimising mass, the precise requirement for a craft intended to be propelled by the pressure of light. The survival of such a tenuous structure over the vast timescales of interstellar travel is a testament to the materials used in its construction. The interstellar medium, while largely empty, is not a perfect vacuum. It is populated by a sparse fog of hydrogen atoms and microscopic grains of dust, each one a potential kinetic projectile for an object travelling at 62 kilometers per second. For a sheet only millimeters thick to survive this multi-millennial bombardment without being shredded into a cloud of metallic confetti, it must be composed of a material with extraordinary tensile strength and resilience. We are looking at a relic of a technology that has mastered the art of the ultralightweight, creating a structure that is simultaneously fragile in appearance and nearly indestructible in practice. This object does not behave like a powered vessel under active command. There are no flickering thrusters, no adjustments in orientation, and no signals emanating from its surface. It is a passive, drifting relic, a piece of derelict hardware that has outlived its original mission. It moves through the solar system with the indifferent grace of a fallen leaf caught in a breeze. The Galileo project identifies it as a defunct interstellar probe, a sail that has been disconnected from its mast. It is no longer steering toward a destination, it is simply following the physics of its own design, a mechanical wanderer that continues to function as a sail simply because that is what it is. The engineering required to deploy such a structure is as impressive as the material itself. To unfurl a sheet of metal 100 meters wide in the weightlessness of space, ensuring it remains flat and taut enough to catch the light of a star, is a feat of precision that humanity is only beginning to contemplate. This is not a rough-hewn tool. It is a refined instrument, a product of a civilization that viewed the crossing of the interstellar void as a challenge of efficiency rather than raw power. By making the probe so light, they ensured it could be accelerated to incredible speeds. By making it so thin, they ensured it would never run out of propellant as long as there were stars to light its way. As it passes through our neighbourhood, 3I Atlas serves as a haunting reminder of the limits of our own terrestrial engineering. Our structures are heavy, bound by the requirements of planetary gravity and the limitations of our chemical rockets. This visitor represents a different philosophy of motion, one that embraces the lightness of the vacuum and the subtle power of radiation. It is a drifting monument to a logic we are only now beginning to decode. It is a piece of high-technology trash, perhaps, but it is trash that has travelled across the galaxy to show us what is possible when the constraints of a homeworld are left behind. The object is now a silent passenger of the solar wind, its 100 meters of metallic skin shivering under the impact of our sun's light. It carries no crew, no living cargo, and perhaps no memory of the world that forged it. It is a passive participant in the cosmic drama, a relic of an advanced age that has become a mystery for a younger one. In its staggering proportions, we find the signature of a purpose that transcends the simple survival of a rock. We see the ambition of a species that sought to bridge the stars with nothing more than a mirror and a dream of the infinite, leaving behind a shimmering sliver of metal to tell their story to whoever might be watching the dark. The stars of the Milky Way are not static lanterns fixed against a permanent dome. They are a swirling river of fire and gravity, each moving according to its own complex rhythm within the grand rotation of the galactic disk. To understand where 3I Atlas began its journey, astronomers turn to the most comprehensive celestial ledger ever compiled, the Gaia star map. This monumental effort, orchestrated by the European Space Agency, has catalogued the positions, distances, and three-dimensional velocities of more than 1 billion stars. By combining this treasure trove of data with the precise trajectory of the visitor, researchers were able to perform a feat of cosmic archaeology, rewinding the clock to see where this metallic sliver was located in the deep past. As the simulation traced the path of the object backward through the eons, a startling reality began to emerge. Over a span of 300,000 years, the line of its flight stretched away from our Sun and into the dark, yet it refused to intersect with any known stellar system. In the time it took for the first modern humans to emerge on the African savanna and begin their long ascent toward the stars, 3i Atlas was already a lonely wanderer, crossing the empty gulfs where the light of a single sun is insufficient to cast a shadow. It did not emerge from the planetary cradle of a neighbour like Alpha Centauri or the bright fires of Sirius. Instead, its origin appears to lie in the no-man's land of the interstellar medium, the vast and silent reaches that separate the spiralling arms of our galaxy. This finding redefines the object not as an emissary from a specific neighbour, but as a true citizen of the galaxy. It is a nomad that has spent untold ages navigating the currents of the Milky Way, belonging to no single sun and owing its allegiance to no specific world. It has crossed the Orion spur and ventured toward the Perseus arm, moving through regions of space where the density of matter is so low that a single atom of hydrogen is a rare find. To travel for 300,000 years without passing close to a star is a testament to the staggering scale of the void. The universe is not a crowded room of celestial bodies. It is an ocean of nothingness, dotted with occasional islands of light, and 3i Atlas has spent its existence in the deep water. The trajectory suggests that the object has survived multiple galactic seasons. While the planets of our solar system have completed thousands of orbits around the Sun, and the Sun itself has moved thousands of light years in its long journey around the galactic centre, this metallic sheet has maintained its steady, high-speed glide. It has witnessed the birth of nebulae and the slow fading of red dwarfs. It has been a silent passenger to the grand evolution of the Milky Way, a witness to the slow-motion collision of gas clouds and the explosive deaths of massive stars. Yet, throughout all these epochal shifts, it remained untouched, a shimmering relic of an origin that has been lost to the shifting tides of the stars. The absence of a clear stellar origin point carries a profound implication. It suggests that the object has been in transit for far longer than the 300,000 years we can accurately map. If we were to rewind the clock even further, into the millions or tens of millions of years, the uncertainties in the positions of the stars become too great to maintain a precise track. 3i Atlas may have been launched from a star system that has since moved to the other side of the galaxy, or from a world that was destroyed in a supernova long before the Earth was even a molten ball of rock. It is a letter with a return address that has been erased by the passage of time and the relentless motion of the galactic carousel. By characterizing the object as a wanderer of the empty gulfs, we acknowledge the true nature of the interstellar voyage. It is not a leap from one stepping stone to the next, it is a commitment to the infinite. 3i Atlas represents a technology, or a natural phenomenon of such rarity that it mimics technology, that is comfortable with the scale of the galaxy. It does not need the constant warmth of a sun to maintain its integrity. It is at home in the cold, a creature of the vacuum that finds its purpose in the very act of crossing the distance. It has become a part of the galactic fabric, a tiny, reflective thread woven into the vast tapestry of the Milky Way. As it now prepares to leave our solar system and return to the interstellar night, it carries with it the data of its brief encounter with our Sun. For a few short months, its path was illuminated, and its secrets were glimpsed by the curious inhabitants of a small, rocky planet. But now it returns to the state it has known for hundreds of millennia, a silent, high-speed ghost moving through the gaps between the stars. It will continue its journey across the next 300,000 years, perhaps passing through other systems, perhaps remaining in the dark forever. We are merely a brief footnote in its multi-million-year narrative, a single moment of light in a journey defined by the eternal shadows of the galactic void. By witnessing its passage, we have caught a glimpse of the true scale of our home, realizing that the galaxy is populated not just by the stars we can see, but by the silent, drifting remnants of everything that has ever sought to cross the Great Divide. The light that bounces from the surface of 3I Atlas is more than a mere reflection. It is a carrier of chemical intelligence, a coded transmission that reveals the elemental character of a world far removed from our own. When the astronomers subjected this reflected glow to the scrutiny of high-resolution spectroscopy, they were not merely looking at brightness, but at the specific gaps and peaks in the light, the absorption lines that serve as the unique fingerprints of the elements. What they discovered was a chemical profile that stands in stark defiance of the standard composition of our solar nebula. While our local neighbourhood is dominated by the lighter elements of hydrogen and helium, with a modest seasoning of carbon, oxygen and silicates, this visitor is composed of a dense and overwhelming abundance of heavy metals. The data reveals a staggering concentration of elements like aluminum, titanium and nickel, arranged in a way that suggests they were not merely present in the environment, but were the primary building blocks of the object's origin. In the history of the universe, these heavy elements are forged only in the final, violent moments of a massive star's life, the supernova, or in the cataclysmic collision of neutron stars. Our own Sun is a third-generation star, born from a cloud of gas already enriched by the deaths of previous suns. But even so, we are a relatively metal-poor system compared to the high-density regions of the galactic disk. 3I Atlas, however, appears to have been birthed in a star system where the process of nucleosynthesis was accelerated to an extreme degree. Its home was likely a region of the galaxy where the cycle of stellar birth and death occurred with a frequency and intensity that our quiet corner of the Orion Spur has never known. In such a place, the nebulae from which planets form are saturated with the heavy remnants of countless explosions. The worlds born there would not be composed of the familiar rocks and ices of the Earth or the gas giants. They would be metallic fortresses, planets where the crust is rich in iron and the atmosphere is heavy with the vapours of exotic alloys. 3I Atlas is a physical fragment of this different reality, a piece of a world built from a fundamentally different elemental palette. It is a messenger from a high metallicity star system, a place where the very foundations of matter are heavier and more resilient. This chemical signature highlights the profound diversity of the Milky Way. We often fall into the trap of assuming that our solar system is a universal standard, a template that is repeated across the 100 billion stars of the galaxy. But 3I Atlas serves as a corrective to this terrestrial bias. It proves that the galaxy is a mosaic of chemical neighbourhoods, each with its own unique history and its own specific blend of the periodic table. There are systems where the ratio of carbon to oxygen is so high that planets may be composed of solid diamond, and there are systems like the birthplace of this visitor, where the abundance of metals creates conditions that are almost incomprehensibly different from our own. The object's composition is not merely a curiosity, it is the reason for its survival. A structure built from these heavy, heat-resistant alloys is perfectly suited for the rigours of interstellar travel. It can withstand the intense radiation of a close pass to a star and the abrasive touch of the interstellar wind without the degradation that would destroy a more fragile carbon-based body. The choice of materials, whether by the hand of nature or the design of an intelligence, reveals a preoccupation with endurance. This is an object meant to last for millions of years, a metallic shard that has turned the violent history of its metal-rich birthplace into a shield against the entropy of the void. By analysing this chemical signature, we are peering into the heart of a distant nebula that we will never visit. We are seeing the results of a stellar evolution that took place millions of light years away and millions of years ago. The visitor is a tangible link to a different kind of sun, a star that burned with a different intensity and died with a different legacy. It reminds us that we are the inhabitants of a specific and perhaps rare type of system, a quiet backwater of the galaxy where the chemistry is balanced and stable. Beyond our borders, the universe is a place of chemical extremes, where the heavy elements that we consider precious are the common soil of alien worlds. As 3i Atlas continues its high-speed flight, it carries its metallic secrets back into the dark. It is a fragment of a story we are only beginning to read, a testament to the fact that the galaxy is far more varied and exotic than our local observations would suggest. We are the witnesses to a chemical reality that challenges our models of planetary formation and interstellar debris. In the gleam of its aluminum and titanium skin, we see the reflection of a distant metal-rich sun, a reminder that the universe is a vast laboratory of elemental possibilities, and that we have only just begun to understand the materials from which the cosmos is constructed. The visitor is a piece of the infinite, a metallic ghost that has crossed the gulfs to show us that even the very atoms of which we are made are but one small part of a much larger and more complex chemical tapestry. The data is cold, and the numbers do not care if they make us feel small. In the silence of the laboratories and the hushed corridors of observatories, the realization has taken hold that 3i Atlas is not a herald of a living civilization, but a haunting piece of technological debris. It is a mechanical ghost, a remnant of an ambition that has almost certainly been extinguished by the slow grinding of the galactic clock. The vacuum of space possesses a quality of profound indifference. It does not distinguish between a natural stone and a manufactured mirror. Both are subject to the same laws of motion, the same erosive touch of cosmic rays, and the same eternal darkness. This object is a message that has outlived its sender, a letter that has arrived at its destination long after the hand that penned it has returned to the star stuff from which it was forged. The creators of this shimmering sheet likely flourished millions of years ago, perhaps in a star system that has since been torn asunder by the shifting tides of the Milky Way. To build a light sail of this scale and metallic purity requires a civilization that has moved beyond the primitive struggle for survival. Yet even the most advanced societies are subject to the entropy of time. If 3i Atlas was once a scout, a scientific instrument, or a piece of a larger infrastructure, its original purpose has been erased by the eons. It no longer transmits data to a homeworld. It no longer adjusts its course to avoid obstacles. It simply is. It is a passive participant in the cosmic drift, a relic that continues to sail only because the physics of its design allow for nothing else. This indifference of the vacuum is the most chilling aspect of the encounter. The universe is not a curated museum of achievements. It is a vast reliquary where the artifacts of the dead are mixed indiscriminately with the rubble of the unborn. We have spent decades searching the radio frequencies for a sign of the life, hoping for a greeting that would prove we are not alone. Instead, we have found a piece of trash, the most profound and terrifying trash in human history. It is a reminder that the galaxy is likely filled with these silent letters, remnants of civilizations that reached out, failed, or simply moved on, leaving their mechanical ghosts to haunt the suburbs of other star systems. The void is not empty of signals, it is a backlog of unread and unreadable mail. To view 3i Atlas as a ghost is to confront the reality of our own eventual obsolescence. We are a young species, our history measured in thousands of years rather than the millions or billions that define the life of a star. Our own probes, the Voyagers, and the Pioneers are currently beginning their own long, silent journeys into the interstellar dark. In 100 million years, they too will be mechanical ghosts, their gold-plated records carrying the sounds of a world that may no longer exist, their electronics dead, their structures pitted by the impacts of 1 trillion dust grains. They will be the 3i Atlas of some other civilization, a curious anomaly caught by the senses of a species that has not yet even evolved. The object does not care that we have named it. It does not care that we have spent months debating its composition and its origin. It continues its 62 kilometers per second flight with a stoicism that is both beautiful and terrible. It is a testament to the fact that intelligence can manifest as a physical object and then persist long after the spark of that intelligence has gone out. We are looking at a shadow of a shadow, a reflection of a light that was extinguished in the deep past. The message of the letter is not a set of instructions or a greeting, It is the mere fact of its existence. It says that once, in a distant place and a distant time, something else existed that could dream of the stars and build the tools to reach them. This realization brings a strange, cold clarity to our place in the cosmos. We are the accidental recipients of a correspondence that was never meant for us. We have intercepted a ghost on its way to nowhere. The galaxy is a graveyard of intentions, a place where the works of the great are reduced to drifting slivers of metal. Yet, in this haunting reality, there is a profound sense of continuity. The vacuum preserves the physical form of our aspirations long after our voices have fallen silent. 3i Atlas is a mirror in more than just the literal sense. It reflects the fragility of our own technological tenure and the immense, uncaring scale of the stage upon which we play our part. As the object moves away from the sun, the light that filled its sail begins to fade, and it returns once more to the shadows. It remains a mechanical ghost, a silent wanderer that carries the chemical signature of a dead world into the future. It is a reminder that the silence of the stars is not a lack of history, but a surplus of it. A history so vast and so old that our own brief moment of awareness is but a single flicker of light in an endless night. By witnessing this ghost, we are forced to acknowledge that we are part of a much larger and more tragic narrative, a story of civilizations that rise and fall, leaving behind only the shimmering remnants of their dreams to drift forever through the indifferent void. The arrival of 3i Atlas coincides with a fleeting, singular moment in the history of the terrestrial biosphere. For nearly 4 billion years, the planet Earth has orbited its star in a state of biological ferment, yet for the vast majority of that epoch it was a blind world. Life flourished in the oceans and colonized the continents, but it lacked the sensory apparatus to perceive the subtle intrusions of the interstellar medium. The great reptiles and the ancient mammals lived beneath a sky filled with wandering messengers, yet they possessed no means to distinguish a common asteroid from a metallic visitor from a distant sun. It is only within the last few heartbeats of cosmic time that a species has emerged with the capacity to build silicon eyes capable of piercing the dark. We live in the 1-second window of cosmic time where our technology is sharp enough to catch the glint of this passing metal. If 3i Atlas had crossed the plane of our planets only a few centuries ago, it would have passed in total anonymity, a silent ghost unnoticed by the rudimentary glass lenses of the first astronomers. If it had arrived a few thousand years earlier, it would have been nothing more than a nameless spark in the peripheral vision of a hunter-gatherer, a momentary flicker lost to the legends of the night. Our current era represents a precarious technological threshold, a period where our optical instruments have reached a sensitivity that allows us to resolve a structure measuring only 100 meters across at a distance of millions of kilometers. We are the first generation of humans who are no longer victims of gravity, but decoders of the silence. This alignment of technological capability and celestial arrival is a profound stroke of luck. The object has been travelling for hundreds of thousands, perhaps millions of years. Its journey began in a distant era of galactic history and will continue long after the current configuration of our continents has shifted beyond recognition. That its path intersected with our solar system precisely when we possessed the asteroid terrestrial impact last alert system is a statistical rarity that borders on the miraculous. We have intercepted a correspondence that has been in transit since the dawn of our genus, catching the light of a mirror that was polished before our ancestors had even mastered the use of fire. In this context, humanity serves as the accidental witness to a journey that would otherwise remain unobserved and unremembered. The universe is a vast expanse where events of staggering scale and beauty occur in total isolation, leaving no record and finding no audience. Stars explode in empty voids, planets are forged in the hearts of lonely nebulae, and interstellar probes drift forever through the dark without ever being seen. Without an observer, these events are merely the cold interactions of matter and energy, devoid of meaning or narrative. By detecting 3i Atlas, we have rescued its journey from the oblivion of the unobserved. We have given a name to the nameless and a destination to the lost. We are the decoders of a silent correspondence, finding a story in the trajectory and a history in the chemical signature. The object itself does not know it has been found. It does not respond to our gaze, nor does it alter its course because it is being watched. It remains as indifferent to our observation as the vacuum through which it sails. Yet the act of witnessing changes us. It forces us to acknowledge that our planet is not an isolated island, but a port of call for the derelicts of the wider galaxy. It transforms the sky from a backdrop of static lights into a dynamic arena of transit and movement. We are no longer merely looking at the stars, we are participating in their history. There is a strange warmth in knowing that even if the sender of this cosmic letter is gone, the message was preserved by the very vacuum that sought to erase it. The coldness of space, which we often view as a hostile barrier, has acted as a perfect archival medium, shielding the metallic skin of 3I Atlas from the ravages of atmosphere and moisture. We have caught a glimpse of a reality that exists far beyond our reach, a physical proof that the creative impulse of intelligence is a galactic phenomenon rather than a terrestrial fluke. Our role as the witness is to ensure that this journey was not in vain, to record the passing of this mechanical ghost so that its story becomes part of our own. The timing of this encounter serves as a reminder of the fragility of our own window of opportunity. We are a species that has only recently gained the ability to see the deep dark, and we do not know how long this period of clarity will last. We are currently in a golden age of discovery, where the marriage of mathematics and high-speed computing allows us to reconstruct the past and predict the future of a wandering sail. This is our moment to listen to the silence and to read the unread mail of the cosmos. By observing the 62 kilometers per second flight of this visitor, we are asserting our place in the galactic community, not as conquerors or as peers, but as the chroniclers of the infinite. As 3I Atlas begins its long retreat into the outer reaches of the solar system, we remain on the shore, watching the light fade from its silver sail. We have captured its image, mapped its path, and decoded its chemistry. We have turned a minute glint of light into a masterpiece of scientific storytelling. The object will continue its voyage into the dark, returning to the anonymity of the interstellar medium, but it will never truly be lost again. It lives now in our records, a shimmering testament to the fact that for one brief, profound moment, the path of a mechanical ghost and the gaze of a curious species were perfectly aligned. We are the ones who give the universe a voice, the ones who find meaning in the drift, and the ones who ensure that no letter tossed into the celestial tide goes entirely unread. The sun is now a diminishing spark in the wake of the traveller, its golden influence yielding to the eternal cold of the outer solar system. 3I Atlas has crossed the invisible boundaries of the planetary orbits, its 62 kilometers per second momentum carrying it toward the frozen ramparts of the Oort cloud and the true interstellar dark beyond. As the distance grows, the data points become fewer, the signals fainter, until the object once again becomes a silent ghost, indistinguishable from the background of the stars. Yet, it does not leave as it arrived. It departs as a named entity, a documented phenomenon, and a permanent inhabitant of the human record. We have performed the most vital act a conscious species can offer the universe. We have served as the witness. The journey of this cosmic letter is a saga that spans the breadth of the Milky Way and the depth of geological time. It began in a star system rich in heavy metals, born from the violent legacy of a supernova that enriched the local nebula with aluminum, titanium and nickel. It was forged into a structure of impossible lightness, a sheet of alloy measuring 100 meters in length but possessing the thickness of a mere whisper. Whether it was the intentional creation of an advanced intelligence or a natural anomaly of staggering rarity, it was launched into the void with a velocity that defied the local gravity of its home. For hundreds of thousands of years, it sailed through the empty gulfs, its 90% reflectivity turning the faint light of distant stars into a source of steady, silent propulsion. It crossed the spiraling arms of the galaxy, a shimmering sliver of metal that carried the chemical signature of its birthplace across the light years, until a chance encounter with a yellow dwarf star brought it into the field of view of a young and curious civilization. By giving a name to the nameless, we have transformed a random event into a meaningful narrative. Without the intervention of the telescopes in Hawaii and the analytical minds that decoded the albedo paradox, the passage of 3I Atlas would have been a non-event, a tree falling in a forest with no one to hear the sound. Our observation granted the object a destination it did not seek, and a purpose it did not know it possessed. We have turned a piece of technological debris into a monument to the possibilities of existence. In the act of measuring its speed, analysing its light, and tracing its path through the Gaia star map, we have asserted that the universe is a place where things can be known, and where the silent correspondence of the stars can finally be read. This is the true importance of the witness. We are the ones who ensure that the grand experiments of the cosmos, the birth of stars, the flight of interstellar sails, and the slow decay of ancient probes, do not happen in vain. We provide the context, the memory, and the language that turns the raw data of physics into the poetry of discovery. We are a small species on a small planet, yet our reach is as long as the light we capture. By looking outward, we define our own place within the vast indifferent machinery of the galaxy, finding warmth in the realization that we are the accidental recipients of a message that has outlived its world. The departure of 3I Atlas is not an ending, but a beginning of a new chapter in our understanding of the interstellar medium. It has proven that the void is not a barrier, but a bridge, and that the objects that cross it are far more diverse and complex than we had ever dared to suspect. It has opened our eyes to the reality of the mechanical ghosts that haunt the suburbs of our solar system, and it has prepared us for the next visitor that will inevitably emerge from the dark. The letter has been read, its secrets glimpsed, and its journey recorded for all of posterity. We remain on the shore of the cosmic ocean, our senses tuned to the next flicker of light, our minds ready to decode the next silent transmission from the deep. This quest for understanding is a collective journey, an ongoing exploration of the wonders that lie hidden in the folds of space and time. To continue this voyage, to delve deeper into the mysteries of the stars and the history of the materials that build our world, is to participate in the most profound endeavour of our species. We invite you to join this journey through the wonders of our cosmos by subscribing to History of the Universe. By supporting the exploration of these deep space mysteries, you become a part of the effort to give a voice to the silence and a name to the nameless. Together, we will continue to watch the dark, to catch the glint of the next passing mirror, and to ensure that the epic story of our galaxy continues to be told. The stars are calling, the letters are waiting, and the journey is only just beginning. Join us as we uncover the secrets of the infinite and bear witness to the history of the universe.